Welcome to the course on the 3M and the 7 Deadly Sins. This course will help you understand the core philosophy of Lean. There is a lot more to Lean, however it's important to know about the 3M and the 7 Deadly Sins, as all Lean tools are targeted towards their removal. The 3M are Mura, Mori, and Muda. Mura is a Japanese word meaning unevenness, irregularity, non-uniformity. Mori refers to stress. Stress on people, tools, machines and process. Muda refers to waste or any activity which does not add value, only adds time and cost. There are 7 types of wastes identified in the Lean way of thinking. Let's do a quick take on these terms with the help of an example. A 100-ton capacity truck is used for hauling a 1-ton load. This is one of the 7 Lean wastes or mudas or overprocessing. The next is an unevenly loaded truck, which is what Mura is. Finally, a very low capacity truck, being used for a heavy load is stress, or Mori. Now let's learn about the 3Ms and more importantly the 7 wastes in detail. Mura is used to indicate an uneven workload on people or processes. A process is a chain of linked events that rely on one another, and it's important to ensure that every component of that process is tasked with a burden that they can handle. The goal is to avoid having too much work, and not enough work for every link in the chain. For example, a healthcare claim process has provider contracting as an upstream process and customer service downstream. The provider contracting process is working on a 30% online and 70% offline mode, verifying and including providers in uneven chunks. This leads to call volume spike at times in customer service when they are not fully staffed for it. This is Mura. This uneven load will lead to quality issues and other forms of Lean waste. What are the reasons for uneven workload? The first is improper work distribution. When work to a department, employee or machine is allocated such that it is too high or too low, compared to their optimal work conditions, then resource starvation happens. This resource starvation leads to quality defects, amplification of defects downstream and also a process, employee or equipment breakdown. Next is variation in cycle time. During inception, different parts of a process are designed to withstand a certain amount of variation in cycle time or service level. When this variation or continuous change in cycle time happens, longer than planned, or at limits higher than designed, it leads to an imbalance in the process and in the ones downstream. For example, a 20 FTE team can handle calls at an occupancy of 75%, which allows enough time for update sessions, huddles, meetings etc. The same team can handle high call volumes, for 2 to 3 weeks at an occupancy of 85%, wherein all meetings and auxes are stopped. However, if this continues for 9 to 15 weeks, without any backfills in headcount, it can lead to drastic reduction in quality, attrition, burnouts, etc. Finally, unorganized work. When a process, or a section of a process, a department, or an employee, is made to start work without adequate or effective training, the resultant work becomes unorganized. A lot of non-value-add activities or Lean wastes happen. This impacts overall quality, high expenses, and also productivity of downstream processes. For example, in a voice process, there is a need to start an escalation queue, and hastily it is started. The transfer protocols are not adequately designed, the staffing estimation of the queue is not accurately done, and the SOP are also not finalized. If this queue continues in this manner, it will create more issues than it will solve and will also impact the overall customer satisfaction. What is the impact of this imbalance? First is impact on quality. Improper load on one section of the process will lead to quality issues, which might creep into the system, and might not be immediately evident. Next is inaccurate capacity planning. While planning capacity, cyclic and seasonal variations are taken into account. The overloaded section of the process will skew the capacity plans for all departments because of the variation in productivity caused by it. Finally, unreasonable and wasteful use of resources and equipment. What can be done to fix Mura? First, adequate staffing and perfect forecasting of work. The forecasting, staffing and scheduling or FSS, should be made as one of the key exercises in business and process management. This will not only ensure imbalance is removed, it also takes care of other wastes, like inventory, waiting, overproduction. Control on cycle or TAT time in each department. Cycle time, turnaround time is a KPI or a key performance index, for any process. Variation control on this KPI done by a slew of strong management practices, including timely and repetitive reviews, a strong project funnel, management intervention, etc., will ensure predictability of outcomes. Standardization of work. A process will have to ensure all SOP are made and updated. Then run GRR initiatives. Finally ensure all personnel trained and new staff are getting adequate attention and assistance. Production leveling. Kanban. The use of different types of Kanban at different stages in the process ensure that pull is happening between sub-processes. We will discuss Kanban in detail in another section. It is important that organizations work on removing uneven allocation of tasks and resources and eliminate more. Doing this helps in taking care of muda tremendously. The best approach in dealing with more is therefore to preemptively introduce measures against it in the fundamental structure of the organization. With a proper foundation, building the rest of the process can be handled much more easily. What is MORI? MORI refers to the waste of stress. Stress of equipment and employees. It is a well-known contributing factor in decreased productivity and employee morale across the board. The tightly interconnected nature of a processes often means that a single department, failing to fulfill their obligations on time, can quickly propagate further down the line. This, in turn, causes issues for others and ultimately the end customer. What are the reasons for MORI? Repetitive work. In a lot of processes, work is designed to be repetitive. After a certain point, this gives diminishing returns. To combat this process, excellence people and champions should design value stream mapping studies, projects or application, and system overhauls, and most importantly automation of redundant work. Unorganized workstation and workplaces. This can be fixed by the 5S method, which we will learn later in the course. Important. Avoid swinging too far in one direction. It's important to realize the danger of overcompensating for MORI, which can lead to a different class of problems. If employees are given too much leeway in completing their tasks, they might be wasting their resources. And this is one of the fundamental types of waste, which we will cover in MUDA. Finding the perfect balance to completely eliminate MORI may not happen, and it might need a few iterations. MUDA. MUDA is waste, or any activity which does not add value and only adds time and cost. What is a value-added activity? As we learned in the section on process mapping, for some activity to be called a value-added activity, three things must be true. First, the customer or client must be willing to pay for it. Second, the thing must be changed in some way, that is, when value-added work is done, the form, fit or function of a thing is changed, and finally, the work must be done right the first time. If any of these 3 points are missing, the step or process cannot be said to be value-adding step. With this definition, all activities in the process can be divided into VA or value-adding activities, and NVA or non-value-adding activities. NVA are further classified into essential non-value-adding or value-enabling activities. These are activities which do not produce any customer value, but are essential for creating another value-added activity, and non-essential non-value-adding activities. These non-essential non-value-adding activities are the 7 deadly sins. MUDA is broken into 7 resources that are frequently wasted. There are 2 acronyms which are used to define the 7 deadly sins or the 7 deadly wastes. TIMWOOD and WORMPIT. TIMWOOD is the most widely used. T is for transportation, I for inventory, M for motion, W for waiting, O for overproduction, O for overprocessing, and finally D for defects. Now, let's look at each one in more detail. Transportation, that's movement of people, materials, products and documents between activities or locations. Transportation is a cost that adds no value to the product but increases the risk of a product being damaged, lost or delayed. All the top 10 organizations of the world have implemented Lean in a highly effective way. There are great case studies on how Dell and Walmart have implemented just-in-time manufacturing and completely eliminated the cost of transportation and inventory. We will be discussing both the case studies in an upcoming course. The next is inventory. Additional inventory, whether it is raw materials, work in process, or finished goods. In other words, any work or material on hand other than what's needed right now to satisfy customer demand is called as inventory. Inventory is just a cost, and it also devalues over time, whether it is excess raw materials or excess finished good. Capital lost on inventory is considered a waste. Motion, movement or motion in an activity that does not add value for the customer. The motion can be of materials, men or even information. After studying the course on process maps, you will be able to quickly identify the non-value-added motion within the process. These can then be taken out using value stream analysis or 5S. Both these will be taught in an upcoming course. Waiting is time wasted between activities, waiting for required materials, resources, people, or information. This type of waste can easily be detected by a well-designed and well-run workforce management team. Overproduction, producing more than what's needed. For example, making 20 copies when only 2 were needed. Overprocessing when more work is done than necessary. Overprocessing is excessive processing and unnecessary duplication of work. This happens when a process is designed in such a way that uses more resources than is truly required. The waste of overprocessing is definitely the hardest to understand. The most common root causes are a lack of understanding of customer needs and specifications. Example may include, doing 100% quality check on all claims processed, when with 95% confidence, we can say that the current sample-based quality check mechanism will be able to catch all defects. Defects: any activity which produces undesired outcome that adds no value. Something that has specifications less than the level the customer, both internal and external, had requested. One example of defect is rework. Another example is a DISAT call, or a call which fails the quality parameters. How to remove the 7 deadly wastes. First,